Hi, and welcome back to Data 602 Advanced Programming Techniques. In this session, we're going to be talking about Amazon Web Services, cloud computing, and specifically EC2. If you're already familiar with EC2, have launched EC2 instances, and know how to log in and use EC2, then this is a session that you may want to skip. However, if you are just getting familiar with EC2, I do recommend that you spend a couple minutes going over this video and jumping around to the sections that you find most relevant. So let's get started. Well, first we're going to define what EC2 is. What actually is EC2? EC2 is a service from Amazon that provides secure, resizable compute capacity in the cloud. So what does that mean? Um, and the best way for me to explain it is to start looking at what has brought us to this point in time in the tech world and why the idea of something like EC2 is even in existence. And that will help us better understand what EC2 is beyond the very jargonic description. So let's start with the old days. This is maybe 10, 20 years ago. If you were a entrepreneur and you were starting up a web-based business or an e-commerce business, obviously you would need the ability to host your software, your web server, your application server, your content. And the way that it was done back then, by and large, was by buying servers and holding those servers on what's called on-premise or on-prem. So let's say you had an office and you set up an office and you're launching a service to deliver food to people's offices, and you would have what's called a server cage, which is what you see in the image in front of you. And you would put in all of the infrastructure that you needed, the internet connection, the servers, the hard drives, the backup systems, the backup power supplies. All of that would kind of be fit into this server cage. You'd have the right cooling environment. You make sure that the temperature was at the right level, and this was somewhat of an expense, an upfront expense. The pros were that you had control over this, meaning that you could walk in the morning and feel good that you had all this gear available to you and it was all yours. The cons were that scaling up was an issue. So let's say you had a spike in the number of users you had a mention on some popular media site, and all of a sudden a ton of users came to your site. What that meant was scalability or adding servers to support the additional capacity of a flood of new users or visitors coming to your site was a potential concern that you would have to address. So if you wanted to get another server, let's say you wanted to put in another server, that was a significant upfront cash outlay. You might be spending anywhere from $10,000 to $50,000 upfront, and so that's not chump change even back then, and the times where a lot of VC money went into a lot of these startups. It was something that you had a budget and you had to purchase, and there was a time frame around getting the server to your location and then installing it using your administrative support uh, group to be able to deploy this. What that meant is that you needed the personnel on site, and that would be something that would be not only an impact to your infrastructure budget, but also an impact to your payroll. And we can come up with an analogy that this is analogous to buying a car, putting a mechanic on payroll, and then also buying the parking lot where you'll park that car. Things then evolved from there to what was called, or what we still have, what's called co-location. And what people decided to do is, hey, maybe I don't really need to have everything on site. I don't really need to have all my servers on site. I don't really need to have so many full-time staff members managing all of this infrastructure. What I can possibly do is go to another company that has a lot of the infrastructure in place. I'll still buy the servers and I'll just go there and put the servers there. They'll give me the cabinet space, they'll give me the rack space, they'll give me the infrastructure, they'll take care of the cooling, they'll take care of cooling the environment. They'll have technical support there if I need help, so I don't need to hire that many full-time people. And this is called co-location. And the advantages of the pros were that it was cheaper, meaning that although you were still buying the servers, your cost per CPU, your total cost of ownership went down because you had less people on payroll, and there was more available in terms of the infrastructure that could be shared across multiple companies. So within one particular rack, what you see here is like a rack which is a vertical shelf space. There may be multiple companies there with their own servers, and because everything was shared, it was overall cheaper per customer, per company. And again, the analogy here would be you buy the car, you rent a parking lot space, and you use a mechanic when you need it. You go to a mechanic shop, or you have a mechanic come over when you need it. And so that's a co-location concept. Fast forward to today, where there's a lot of, you hear a lot about the cloud, and the cloud is something like this. And I'm using this picture. This is a bit of an exaggeration, but the point here is that you really don't have any infrastructure that you really are holding on to that's sitting on your balance sheet or anything like that. Everything is off your premise and on sitting on another company's location, and they're managing everything for you. You're not even buying servers. So the servers are already available to you. You don't need to purchase anything, and you're basically leasing everything. And the analogy here would be that you are leasing or renting a car, you lease or rent a parking spot, and you go to you use a mechanic when you need it. Basically, everything is leased. And here's a chart that I put together to kind of demonstrate where the industry has gone. So we have on the left here where you're buying everything. So you're buying your physical space, you're buying the rack space, you're buying the servers, you're buying your administrative support, you're buying the infrastructure apps like your web server, your application servers, your email servers, and you might be buying apps and installing apps that you use. And there's a shift as you shift to the right. Um, Less and less of it is on premise, and more of it is in the cloud or off premise, and more of it is leased. So the more of this that you are leasing, the more you kind of are in the cloud. And so the cloud is really leasing this entire stack here. And so theoretically, you're shifting your costs away from purchasing things to actually just leases. And in the accounting world, this is called CapEx. CapEx means capital expenditures. So you're moving things from your capital expenditures, which are like upfront costs on sort of buying stuff. You're moving it to operating expenditures, which is your recurring payments that you're paying off every month or every quarter, and they are significantly less than this big upfront payment. So this shift towards the right is really where the cloud is kind of uh, uh, emerging. Now, we mentioned resizable. This is actually the server farm for Google Cloud, and they have close to, let's say, 1 million servers, probably a little bit more by now. And you never get to see this. So if you're a business and you're running your application on the Google Cloud platform, uh, you will never walk into a location like this. Unlike on a co-location place, you would send in your technology support people to go in and physically work with the staff there, and to physically place your servers in, and versus the server cage which you had on premise, which you would see basically on a daily basis. Here you would never see this server farm. uh, all you do is allocate space that you need, server space that you need from a dashboard, and we're going to get into that. We'll show you how that's done. So that's the idea, that you can resize means that your application can take up these many servers here. Let's say they take up 5 servers here, and then you need to expand because you have an immense load coming in because of some media coverage. You can easily expand your application to cover and consume another additional 5 servers, or additional 20 servers, or additional n number of servers. And these servers don't necessarily need to be physically next to each other. You could be using this server here, and this server here, and this server here, and another server down in here, and they're all acting as a single a conceptual server for your or logical server for your infrastructure. And so that's the importance of the cloud. You can resize when the and your costs will go up as your load goes up. But however, let's say after the media news kind of washes through its news cycle, the number of users that are coming to your site go back down to some normal level, you can start to release some of these servers and reduce your costs. And that's one of the benefits of cloud. The resizing means that you can scale up and your costs go up in accordance with the load, and then you can also scale back down. Now, Amazon Web Services has at this time roughly around 2 million physical servers worldwide. That's an enormous amount of capacity, and this statistics is based on a Gartner report, and they are consistently adding servers on a monthly basis. So what happens when you're doing this? Companies like Amazon are the leader is a leader in this space. What they do is they add more infrastructure, they add more servers that provides economies of scale, and then for the customer, they are able to provide reduced prices. So let's say you wanted to use a server, your cost per month goes down because their cost goes down as well. So the more they're adding, the lower per server their cost goes down. That allows them to reduce their prices, and that brings on more customers, right? And that makes AWS more useful, and so people are spending more on AWS. They're getting more customers, and so then Amazon has more money to build up more infrastructure, and this just keeps on going. This cycle keeps on going, and it's really uh, as we can see with Amazon having 2 million servers, this is really something unique in the history of computing. Now, is Amazon the only one that's doing this? There are a bunch of providers out there. The leading ones are these three companies: Google, Microsoft, and Amazon. I would guess that Amazon is significantly ahead of the other two, and that is one of the reasons that I'm actually using Amazon Web Services for this course, because they have, in terms of the infrastructure and the number of applications that are running on those infrastructure components that you can use, is significantly far more than what Google and Microsoft has. So that's why I've decided to use Amazon. Now, if you, just to go back here, if you are in this cycle as a technologist, and we're all technologists, as a data scientist, that you see this going down, what it means is that more and more applications are going to start moving onto here. What that means is more types of data analysis will move on here, more types of data will be sitting on here, and your skill set in terms of being marketable in this market means that you should know the tools that are behind Amazon Web Services, and one of those tools is EC2. The ability to be able to spawn up 300 servers to compute something for 5 hours and then shut them down and discard them is immensely valuable. And it's not something we could do easily 10, 15 years ago. So this is a screenshot of the Amazon Web Services homepage. You can go to Amazon, just go to aws.amazon.com, and you can explore a little bit around what they have. You can see that they have a ton of different products, and there's a lot going on. It's a very, very busy page. And if you're in New York City, Amazon actually has what's called Amazon Pop-Up Loft in Chelsea, and it's a great place where you can actually sit there for free. They provide co-working space for free. But in addition to that, which I think is far more important, is that they have a ton of classes there that they're providing information to the attendees there on a lot of their products. They have architects on staff there where you can sit down and discuss and work out solutions for some of the projects that you may be working on. And it's entirely free. I urge anybody that's in New York City, and they also have pop-up lofts in other cities. Just Google AWS pop-up loft, and you'll see the different cities that they have that are available. So if you're ready to get started with AWS, and if you're ready to get started with working with EC2, because in a couple of minutes we're going to do a EC2 demo. We're going to walk through how to launch an EC2 instance. Make sure you set up a free account. To do that, go to this URL at Amazon. Provides free accounts for people with .edu domains. So please do that right away. It can take a day or two, maybe even 3 days to get this approved. And once you have that, we make sure you're logging into that and that you are on the free tier, meaning that you're not being charged. Even though they may take your credit card information, make sure that they're not charging you for the account. Now, AWS, in addition to EC2, has a plethora of other products. You can see up here, this is a kind of a catalog of the products that they have. EC2, or the services that they have, EC2 is one of them, and they have a bunch more. The ones that you're really going to be concerned with, probably for this semester, is going to be EC2, maybe S3, and S3 is for storage. It's like Dropbox. It's like unlimited Dropbox. They have an enormous amount of storage space that you can use, and it's dirt cheap. It's pennies on the gigabytes per month. And in fact, Dropbox actually behind the scenes is using S3 for its Dropbox product. There's also RDS, which is their database, which allows you to use MySQL, MariaDB, and a bunch of other databases. And there's a ton of other products. They're covering different spaces, the game world, IoT, artificial intelligence, and so on and so forth. Each one of these can take, a couple of weeks to just to figure out and play with. Some of these are pretty involved. However, we'll be starting off with EC2. So let's come back. We'll come back full circle. What is EC2? A service from Amazon providing secure, resizable compute capacity in the cloud. We got that. Let's decipher it based on what we just covered. In plain English, EC2 is the ability to create and destroy virtual servers. Virtual servers are what we call computing capacity of almost any size. I can create a server with 10 CPUs with X number of gigabytes of memory, and I can create them instantly. And I can create as many of them as I want. And within, I can't create 10 billion of them, but if I want to create one server or 10,000, I can actually do that. And you can then manage all your servers from one dashboard. And so the fact that you can resize it, you can create 10 servers today, another 50 next week, 300 the week after, and then kill off and destroy half of them if you don't need them anymore, and it doesn't even matter. So that's what EC2 is. It's the computing capacity portion of the Amazon Web Services. S3 is the storage portion of that. RDS is the database portion of that. So in order for you to launch an EC2 instance or launch a server, very quick and few steps that you would execute would be the following. First, you would log in into your AWS account, and you'd be presented with the console. You would click on a button called Launch Instance. It's a blue button. You click on it. You select the size of the server, basically the number of CPUs, the amount of memory that you want. You would specify what ports you would want open on that server, whether it's port 80 if you're running a web server, port 5000 if you're running Flask, for example. And then you would download a private key to be able to log in and SSH into the server, and you're done. Alternatively, you can use an AMI. An AMI is a snapshot of an EC2 instance that someone has taken. It's kind of like a template for a server. It will tell the EC2 what's already installed on that server, and you're basically reviving that snapshot. You select the size for the server, you open up ports, and you download a private key for the login. So what we're going to do next is we'll do a demonstration of this, meaning how to launch a EC2 instance, and then we'll do a demonstration of how to launch an AMI, and it kind of go into more detail around what AMI is. So the first step you need to take in order to launch an EC2 instance is to log into AWS. I've just logged into my account. Now I apologize, some sections of my screen will be blurred out because there is some sensitive information that I have in these accounts. These are some of my actual servers. I have multiple accounts, but these are some of my actual servers, and IP addresses and things like that will be blurred out because this video will be on YouTube, and there's no telling who may be looking at some of these videos. Once you've logged in, you're going to see a dashboard like this. This is AWS's dashboard, and again, you can see all of the products that are available. What we're going to be using is EC2, so we'll click on EC2 under the compute section, and then we'll get the EC2 management console, which allows us to manage all our instances. And this tells us what number of instances we're running, and some other pieces of information. The button that I really want to focus on is this blue button here, which is launch instance. And in order for me to create an EC2 instance, this is the starting point. So I'm going to click on launch instance. Once I do, I'm presented with this screen where I can select in a Amazon machine image, which is basically a template containing the operating system and any other things that it may already have included and installed. So I typically use the Amazon Linux AMI. Amazon has its own Linux distribution, and it comes with Python, Ruby, Perl, and Java already installed. And there are repositories for other things. So I typically use this, but you're free to use any of the other AMIs. You can actually start up a Microsoft Windows server if you want to. So what we're going to do for this video is start up an Amazon Linux AMI, and to do that, I'm going to hit select. Now on this screen, you're going to select this type of server and size of the server that you want to spin. Up. So AWS has multiple different sizes, and they have different tiers. The tiers of the sizes are broken down by these two characters: T2, M4, M3, C4, and so on and so forth. And these all represent different characteristics of the type of servers that could be useful. So if you were going to do animation, for example, you were building, you work for a company that does animations, and you want to start rendering these video of the animations, the type of server you might use is something like, let's say, a GPU based server, which has these many CPUs and this much gigabytes of RAM. And that's something that you would want to select. And Amazon has various types of servers, and what you really need is going to depend on what type of application and how you're going to use that server. And these tiers all have different pricing. Pricing is not within discussing the pricing is not within the scope of this video. However, you can just Google AWS EC2 pricing, and you can see what the pricing structure is for a lot of these servers. They charge per hour, and you can calculate what a monthly cost would be from that. The type of server that we're going to be using is either the T2 Nano or the T2 Micro. We want to use the T2 Micro because you can see that it is free tier eligible. If you use anything more than that, anything bigger than that, which is anything below this, you are going to be incurring some charges, which you kind of want to avoid unless you're fully aware that you are willing to do that. So we're going to select that, and then we'll click on next, and we'll configure instance details, and we'll see this here. We're going to leave pretty much everything as default, and then we're going to add storage. We'll go on here, and you can see that 8 gigabytes are going to be allocated to this EC2 instance, and we're not going to change anything here. There's an SSD that's going to be attached to it, and we can leave that. And we go to tags. Tagging is just a key value pair that we can associate with the EC2. It's arbitrary. You can name any set of tags. It allows you to search for things. So if you have 1,000 different servers and you need to find the 17 different servers that have to do with one particular type of application, tagging up these servers allow you to be able to specify that. So you might have a key called app name and a value where you have the name of the app, and then you can search by the app name. Next, we'll go to the configure security group. This is where you're going to specify, and this is where you're going to make your changes. This is where you'll specify what port you want opened up. By default, you're going to have port 22 open, which is for what you need for SSH. We're also going to add in, let's say, for example, we'll add in HTTP for port 80, and it's automatically going to be set to port 80. We can also add in another one. Let's say it's port 5000, and we'll open up port 5000. We'll just copy and paste this, and then we hit review and launch. Once we hit review and launch, uh, we will be able to then generate a key, private key, which we can then download to use and log in via SSH. And in this session, we're going to be using PuTTY to do that. So now I'm going to hit review launch, and hit launch. And it gives us a review of what the options that we've selected. I launch, and I'm going to say here that I'm going to create a new key pair, and this is what you want to do. So what you're going to say is, let's say my EC2 key pair, and download the key pair. And I'm going to need to keep this. This is downloaded. I need to make sure I keep this in a safe location. This is something that I'm going to need to be able to log in into my server. If I lose this, I will not be able to log in. That's a separate problem. But however, this is downloaded in a format called PEM. In order for us to log in, we're going to have to convert this. If we're going to be using PuTTY, we're going to have to convert this into another format. We'll go over that in a couple of minutes. The important thing to remember here is that to log in into the EC2 instance, it's just not a username and password, but you actually need a encrypted key to be able to get in. Once you do that, you're going to click on launch instances, and the server is launching, and I'm going to go to view instances, and I'll see right here, this is my server that I just launched. I'm going to click on it, and this is the server that I just launched. It's initializing. It actually is ready to be logged into. Even though it's initializing, I should be able to log into it right now. The IP address for the server is this. It's allocated an IP address. I can stop and start the server if I want to. If I terminate it, that means it's going to be deleted, and it'll go away from my dashboard. But you can see that the server will be up and running in less than 30 seconds, and I'll be able to log in and start using it. So the next thing I need to do is convert the .pem file into a .ppk file, which is going to be my private key, which will allow me to log in into this instance. And we can see that the instance is now in a state that's running. This is the IP address for the instance that I'm going to use to be able to log into it. However, what I need to do first is to convert this file over, and for that I'm going to be using a tool called PuTTygen. Now, in order to log in using SSH, I'm going to use a tool called PuTTY, which is a free SSH client, which you can download. Just Google PuTTY, P-U-T-T-Y, and you should be able to download that. And if you run it, it's going to look like something like this. It's simple, a little free tool that you can use to SSH into servers. And on the same website, you're going to see another tool called PuTTygen, which is a tool that allows you to generate the private key and convert the file from a PEM to the PPK file that we need. So PuTTygen is also free, and what we're going to do is we're going to click on the load button, and we're going to select the PEM file that we downloaded, which is going to be right here, my EC2 key pair, and I'm going to hit open. I'm going to click OK, and then I'm just going to click Save Private Key. So, and I'm going to save it without a passphrase. The passphrase allows me to have an additional level of security, and so anytime this key is used, a request for a password will be asked. I'm going to skip that. However, I do recommend that you do put a passphrase in. So I'll click Yes here, and we'll save this as my EC2 key, and I'll just save that like that, and I'll save it as a PPK file, and we're done. Now I'm done with the PuTTygen. Now what I'm going to do is configure PuTTY to be able to log in. It needs an IP address. It needs to know what where the server's at. So I'll put in the IP address. I can save the session. I can give it a name. So I'm just going to say my first EC2 instance, and I'm going to hit save, and I'll save it, and you'll see that it appears here, and I can always come back and open it up and load it. I'm going to also assign to this login the PPK file that we just created, I'll just go to this menu option here on the left, click on Browse, find the key that I just created, which is right here, click on Open, and then I go back to the top here and I make sure I hit Save again. That saves the association between this configuration and the key file. And then when I'm ready to connect, I'm just going to click on this Open, and it connects me into the instance. The login is going to be EC2 user. It's not going to be root for the Amazon Linux AMI. And when I log in, I see that I've logged in, and it's fine, right? And this is me SSHing into this server. So now let's say I've used this instance. I'm done with it. I don't want to use it anymore. I can do a couple of different things. I can change its state from started. It's currently running. I can stop it, which would also stop the billing. I can reboot it or I can terminate it. Terminate it means that it will stop and then it will get deleted and it will not be in my console after a couple of hours. So what I'm going to do here is, because I'm done with this instance, I'm just going to terminate it, and I'll never see this instance ever again. Anything that I've installed on the server would be gone. So this is not something you want to do on something that you've done a lot of work with. However, if you are starting up instances and are running some things and then you're done, you can then terminate it. Or at minimum, you can stop it if you don't want to use it but want to maintain the state. So, so let me just terminate this, and it's terminating. So that's that, and we'll see that shutting down, and eventually this server will not be on my console. The next thing that we're going to look at is launching an EC2 instance using an AMI. If you recall, an AMI is an Amazon machine image, and an AMI is a snapshot of a virtual server at a particular moment in time. It stores that snapshot, and then we can launch brand new EC2 instances based off of those snapshots. So let's take a look at how that works. So when we originally launched an EC2 instance, we used the launch instance button to start a EC2 instance, and we had to select a particular AMI. These were predefined, already prepackaged and prepared by Amazon images that we can launch a server from. However, we can also create an Amazon machine image ourselves and launch a custom AMI, and that's exactly what we're going to do now. I've already created a custom AMI that we can use, and you can see that here under my AMI, and this is the AMI that I created called Data 602. This AMI is public, meaning that you would have access to this, and the way to get access to it would be using this link here. And the minute I hit enter, this link will redirect to a public link on Amazon Web Services that allows us to start this AMI image. So if I hit enter, we're going to see that the launch instance wizard is going to be called with the AMI ID number. Now this AMI that I created, this image that I created already contains Docker, it contains Git, and it contains 2 of the Flask web app from the GitHub repositories that we have. I kind of get you started with all of that, and all I need to do is hit that URL and make sure I'm logged into my AWS account, and it will start the same process that I was going through when I wanted to launch an EC2 instance. I won't repeat that process, but the process is identical, which is basically you're picking the instance type, and then you're going to configure the settings, which you're going to leave as default. You're going to leave the storage as default. You're not going to add any tags. You're going to open up a couple of ports like port 80, port 81, port 82, port 5000, and then you would review a launch and you would create a key pair or use the one that you already created. So you can choose an existing key pair, and this one that you already have here, you can use that. You can use the same key pair across multiple servers. And once you hit launch instance, the instance that you get will already have the Docker and the Git because I've already installed it on a EC2 instance, took a snapshot of that. That snapshot became an AMI, and this AMI I made it public, and you're able to access that snapshot via that bit.ly link that I just put up, and that should get you going. And this is how you get a AMI, use an AMI to launch an instance.